Okay, section 3.7 is equations of lines in the coordinate plane. So the first thing we're going to look at is the slope. The slope, which is denoted by m of a line, is the ratio of the vertical change, rise, to the horizontal change, or run, between any 2 points. Now this should all look familiar to you. So there are 3 ways to show slope. One is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And this is the difference of the y values divided by the difference of the x values. And that's one way to look at slope. Oh shoot, this is not working well. We're going to keep, there we go, difference of x. Okay? Another way is considered rise over run. So when you're counting on graph paper and you're trying to count between 2 points, we can either count from this point as point 1 to point 2, the rise, which is the up and down, and the run, which is the right and left. Or if I start at point 2, my rise here would be down and my run would be to the left. You can count either way. You can either count up and over or down and to the left. The last one, and this is called delta y over delta x. So this triangle shape is the Greek letter delta. And in Greek, we use that word to mean change. So another way to read this is the change of y over the change of x. And the difference of the y values is the same as the change in y. How much did y change from one point to another? So those are 3 different ways of looking at slope. So if I want to find the slope of a line, I have a couple ways that I can do it. If I have graph paper, and I have a point here at, let's say, 3, 1, and then I have another point at -2, -2. If I have that on graph paper, I can simply pick one point to start at. Let's say I want to start here. And I would count my up and down distance, and this goes down 3 units. That's a -3 from 1 to -2. And then I would have to move to the left -5 units. So the slope here would be -3 over -5, or 3/5. If I started over here and used this as my first point instead, I would then count up 3 and to the right 5. So that would be a +3 and a +5, still 3/5. If I use the actual order pairs, 3, 1 and -2, 2 into our formula, it would be y sub 2 minus y sub 1 over my x sub 2 minus x sub 1. So I would get, what did I do wrong? 2 minus 1, -2 minus 3, 3, 1. I'm getting a different answer, which is not good. 2 minus 1 is 1. Oh, this should have been -2. I'm sorry. That makes all the difference. All right, -3 over -5, which is 3/5. Labeled that point wrong. Scared myself for a minute. So anyway, whether we use our formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or whether we count, or whether we count on the graph paper, we're still going to get a slope of 3/5. Okay, we're also going to look at forms of linear equations. You should have done all of this in Algebra 1. The first is the slope-intercept form, y equals mx plus b, where m is the slope. B is the y-intercept. So you're used to seeing something like y equals 2x plus 1, where 1 is the y-intercept. We go up on the y-axis, and then counting a slope of 2 would be up 2 and to the right 1. And that's how we graph this. The other form is the point-slope form. Y minus y sub 1 equals m times x minus x sub 1. Again, m is the slope here, but the ordered pair x sub 1, y sub 1 is a particular point or a unique point on the graph. It's not the y-intercept, but it is a point. So y plus 3 equals negative 1, x minus 2. So the ordered pair, the x value is 2 because x minus x sub 1. The y value is negative 3. Look at the equation of the model, y minus y sub 1. So if I have y plus 3, if I try to make that fit my model, it would be y minus negative 3. So my order pair is 2, negative 3. My slope is 1. So I can plot this using this method: to the right 2 and down 3, and then counting a slope of up 1 to the right 1, my line would look like this. So the two different forms, slope-intercept and point-slope, can be used. So if I want you to write an equation from a line, from a graph, or from given points, I give you a graph, and I tell you that we're going to cross here at 3, and then I'm going to have maybe another point here. So since I have graph paper, I can count the slope right on the graph. It's down 2 and to the left 1. So the slope is down 2 to the left 1. And my y-intercept, or b value, is 3. So for this one, I can use slope-intercept. Y equals 2x plus 3. So that's one example. If I give you another example where instead of giving you the graph, I just give you some points, 2, 4, and negative 1, 5. So the first thing I have to do is find the slope, y minus y over x minus x. That would be 1 over negative 3. And then using my model and picking either point, I'm going to pick the first one because then I don't have to have a negative in there. Y minus my y value equals my slope, and x minus my x value. Okay? So two different ways to write an equation of the line using either information from a graph or information given. I know that most of you are more comfortable with your y equals mx plus b, but I want you to work at learning this form and using it more often. It's a much more versatile form, and we're going to use it more as we go along. And that's it.